We tend to think of our skin as just, well, wrapping paper for our bodies, right? But what if I told you it's actually your body's largest, most complex, and most dynamic organ? It really is. It's the living, breathing interface between you and the entire world. And we're about to see exactly how it all works.
And when I say largest, I am not kidding. Just think about this for a second. Your skin makes up about 15% of your total body weight. That is a massive, multifunctional system that we are carrying around every single day. So let's get to know it a little better. So, what is all that mass actually doing? Well, our skin is our primary interface with the world. It's our protector, it's our sensor, and it's our regulator, all in one. It's this incredibly sophisticated system with tons of different jobs, and to really understand how it pulls all of that off, we need to look at its fundamental architecture. At its core, the skin is organized into three main layers, each with its own specialized role. You've got the epidermis on the outside, that's our protective barrier. Right beneath that is the dermis, which is kind of like a busy support help, and deeper still is the hypodermis, the insulator. We're going to start our journey from the top down. So, our journey begins with the epidermis. Now, this isn't some static layer, it's a living, moving wall that is constantly, and I mean constantly, renewing itself. This is our first line of defense against literally everything the world throws at us, from germs to sunlight. The main characters in the story? They're these cells called keratinocytes. These guys are the workhorses of the epidermis. Their whole job is to produce a really tough, fibrous protein called keratin. You can think of these cells as the bricks, and that keratin they produce is the mortar that holds that protective wall together.
And check this out. These cells go on an incredible journey. A brand new keratinocyte is born way down in the deepest layer of the epidermis. Then, over about 4 weeks, it gets pushed upward by all the new cells forming beneath it. As it rises, it matures, flattens out, and eventually dies, reaching the surface as a dead keratin packed cell that just gets shed. This constant turnover is exactly how our skin stays so tough and repairs itself.
And this whole system is smart, too. It even adapts to its location. So the skin on the palms of your hands and the soles of your feet, that's what we call thick skin. It actually has a whole extra fifth layer for added durability where you need it most. The thin skin that covers the rest of your body, well, it does just fine with only 4 layers. But the epidermis does way more than just form a physical wall. It also manufactures its own incredibly effective sunscreen. And that brings us to this fascinating molecule that's responsible for our skin's color and its defense against the sun, melanin. So meet the pigment factories. These are specialized cells called melanocytes. They hang out in the epidermis and just churn out melanin inside these tiny little packages called melanosomes. Then they hand off these packages to the keratinocytes around them, giving them this amazing protective shield against ultraviolet radiation. Okay, so how is this pigment actually made? Now, don't worry, you don't have to be a biochemist for this. It's a pretty complex recipe, as you can see, but all you really need to know is that there's one key enzyme called tyrosinase that kicks the whole thing off. It takes a simple amino acid and starts the chain reaction that eventually becomes melanin. And get this, not all melanin is the same. There are two main types. You've got eumelanin, which is the brown-black pigment that's way more efficient at blocking UV rays. Then there's pheomelanin, a red-yellow pigment that you see more of in people with lighter skin and red hair. The specific ratio of these two is what gives you your own unique skin tone. So our skin has these pigment factories just ready and waiting. But what's the trigger, right? What tells them to kick into high gear when you step outside into the sun? In other words, what's actually happening when you get a tan? Well, the answer is in the light itself. Ultraviolet radiation, or UVR, from the sun acts as the direct trigger. It's pretty wild. As this diagram shows, it sets off a chain reaction inside the cell. That signal travels all the way to the nucleus, which then sends out the orders to start making more of those melanin-making enzymes. That is what creates the tan that shows up a couple of days after you've been in the sun. All right, let's dive a little deeper. Right beneath that constantly renewing epidermis lies our next layer, the dermis. Now, if the epidermis is the protective wall, you can think of the dermis as the bustling utility hub that supports the whole operation. It provides structure, nutrients, and all the communication lines. I mean, this layer is absolutely packed with critical infrastructure. You've got collagen and elastic fibers that act as the scaffolding, giving your skin its strength and flexibility. You have a dense network of nerves. That's the wiring for your sense of touch. And, so important, you have the plumbing, a rich supply of blood vessels, plus all your hair follicles and glands. In this plumbing system, these blood vessels is absolutely vital for one of the skin's most important jobs, regulating your body temperature. So, how exactly does it keep you from overheating on a hot day or, save that heat when it's freezing cold?
It's this really elegant and dynamic process. To cool down, the blood vessels in the dermis get wider. That's called vasodilation. This brings more warm blood closer to the surface, letting that heat radiate away from your body. And to stay warm, the exact opposite happens: vasoconstriction. The vessels get narrower, reducing blood flow to the skin and keeping all that precious warmth deeper inside your core. It is literally your body's own climate control system.
Okay, so we've seen the regenerating barrier of the epidermis, we've met the pigment factories, and we've explored the deep support system of the dermis. But the real magic of the skin is that none of these systems work alone. They are all part of one beautifully integrated organ. Let's just put it all together for a second. Imagine you're outside on a sunny day. That UVR trigger we saw is kicking off the melanin recipe to protect you from radiation damage, while at the exact same time, the blood vessels deep in your dermis are dilating to release excess heat and keep your core temperature stable. It's this complex, coordinated, multi layered response to a single change in your environment. Just incredible.
And this isn't just some cool biology lesson, you know? Understanding this microscopic architecture is fundamental to so much in real world medicine. It's the basis for how we figure out wound healing, how we develop new skincare, and even how we pioneer new fields like thermopharmacology, which tries to change body temperature by targeting these exact pathways.
So the next time you happen to look at your skin, just remember everything that's happening right beneath the surface. It is your barrier, your thermostat, and your built in sun shield, all constantly working and adapting for you. So the question is, what story is yours telling?